This lecture is about software maintenance reverse engineering. Reverse engineering is the reverse process of the development process. This process converts the code to recover the design, requirement specification, and problem statement. Reverse engineering is the process of analyzing a system to identify its components and their interrelationships, and creating representations of the system in another form or at a higher level of abstraction. In comparison, the traditional process moves from a high level of abstraction to a physical system. Performing reverse engineering manually is difficult. Therefore, tools are developed to automate the process. The main components of a reverse engineering tool is shown in the figure. The tool takes the code as input and displays the design diagrams as output. The first step of the reverse engineering process extracts the software artifacts from the code. For example, to reverse engineer an object-oriented program would be to generate a class diagram, the classes, their attributes and operations, and the relationships between the classes. The diagrams used by reverse engineering have a number of uses. 1. Program understanding. The diagrams are useful in facilitating understanding the structure, functionality, and behavior of software under maintenance. This is useful when the system documentation is missing, outdated, or inadequate. 2. Formal analysis. Formal analysis techniques can be applied to the diagrams produced by reverse engineering to detect problems that may exist in the software. 3. Test case generation. The diagrams produced by reverse engineering facilitate test case generation. This diagram is an example of an object relation diagram. This component takes the source code and produces a UML class diagram showing the relationships and the attributes and the methods of the classes. The object relation diagram utility includes change impact analysis, software metrics, version comparison, test order, block branch diagram (BBD), object interaction diagram (OID), and object state diagram (OSD). Here, classes are expanded to view the details. The node class and the connection point pair classes are expanded. Change impact analysis is shown here. When the classes in red changed, the affected classes are in gold. Or layout class changes affect many classes. The leveling class, when changed, affects classes C class, relation, and linked list. Metrics include, for each class, the class size, the number of lines of code, the number of children, fan in, fan out, the number of relationships, depth of inheritance, and so on. This utility computes the order to test the classes so that the effort required to implement the test stubs is substantially reduced.